Go. Hello and welcome back to Statistics1. We are starting chapter 4. This is like part 3 of the whole statistics curriculum here, and we are looking into probability and some random variables and other things that are coming up. So chapter 4 will be about probability, and hopefully you will learn that you shouldn't gamble in this chapter because it's a colossal waste of money. We'll calculate the odds of all of those things. We'll play a lottery, and we'll do some of the casino games as well, just to see how unlikely is to actually win in any one of these. So to begin, we first need to just define few terms. This is extremely short lecture. And the first off is when we say probability, we mean the chance. What are the chances that something is going to happen? So that's the simplest way to understand, and we would like to quantify that and give it some kind of mathematical measurement, and we measure things using numbers. So when something is 50% likely to happen, 20% likely to happen, 100% likely to happen, we're going to learn what that means. So we start by understanding that probability is going to be some kind of a measure of likelihood of some event happening. So it's not definition is just understanding what it is. So probability is a quantitative, so numbers, quantitative measure of likelihood of an event happening. Now, if we flip a coin, so flip a fair coin, so one that has heads and tails on it, and it's well balanced and it's not tampered with in any way. So if you flip a fair coin, there are two possibilities. Heads or tails. And now likelihood of each one turning up is 50%. So it's half and half. Now this means that if we are to flip this means if we are to flip a coin 100 times, we will count about 50 heads and 50 tails. Will it be exactly 50 heads, 50 tails every time? No. But it's going to be very close to 50-50. You can roll a fair die with numbers 1 to 6, and there will be 1/6 of a chance to see any particular number you want. To pick a card out of the standard deck of cards, that would be 1 in 52 to pick a particular card. If you are trying to draw or not trying to draw the short straw, and there are 4 or 5 of those, there is a chance of getting the short straw or not getting a short straw. When you are looking up the weather, they tell you chance of rain or chance of snow or chance of whatever falling out of the sky, frogs or whatever, is going to be 20% or 100%. So they give you an estimate, and if I say, or they say, chance of rain is 70%, what does it actually mean?
30% won't.
Yes, it means 30% it won't. So now there's more chance that it will rain than it won't. Because 70% of rain means 30% it won't rain. So there's more in a bag that it will rain than in a bag that it won't rain. 50% means either way. So we are looking into this probability, and we want to write a formula that probability of an event is equal to the frequency divided by total number of possible outcomes. So this is our formula. F is the frequency so number of ways in which the event can occur, and capital N is total number of possible outcomes. There wasn't a full sneeze. There was just a boo. That's it. Just a boo. That's it. Total number of possible outcomes. So now I'm going to draw 6 of these, representing 6 different faces of a die. All right, so now when you're looking at the formula above, and say you are looking to roll a 6, your F is equal to 1 because there is only one way to get a 6 if you roll a die, if it's a fair die. Can I construct a die that has 6 numbers to be 6? Sure. Right? You can take a regular die, just put stickers on each side, on other 5 sides, with the likes of a 6, and that's it, right? And you have a 6-sided, 6-only die. So you can do that. But if you are rolling a fair die that has only 1/6, the number of outcomes in which the event can happen, which is roll a 6, is exactly 1. because there's only one 6 on those 6 sides. And the number of possible outcomes is 6, because there are 6 sides of a die, of a cube, right? 6 sides, and each one has a different number. So your probability to roll a 6 is simply 1 out of 6, because it is one way to roll a 6 out of 6 possible sides. Pick 7 of hearts. Well, probability of 7 of hearts is going to be, there's one 7 of hearts in 52 cards. To pick a heart, well, that's going to be 13 out of 52, which is exactly a quarter of a deck. The deck has 52 cards, has 4 suits, and one of those 4 suits is the hearts. So there is exactly 13 cards that have hearts. Ace, number 2, number 3, number 4, number 5, going all the way through 10, and then Jack, Queen, and King. So there are 13 cards that have hearts on it, and the rest of the cards do not have heart on it. And to pick number 7, well, there are 4 cards out of 52, so 1 over 13 chance of picking a 7. So looking at these, what is the most likely one to win? To pick a hearts, right? Because the hearts has the largest number. Now we can go take the calculator and compute the decimals. 1 divided by 52 is 0.019. This is about 2% chance. About 2% chance to pick exactly the card you want out of a deck of 52 cards. This one is obviously 0.25, so that's 25% to pick what you want. And then 1 divided by 13 is going to be about 0.077. So it's about 7.7% chance to pick. So you see that the 25% to pick a heart is the best chance out of all of these. Is there something that we can actually pick that is even bigger probability than picking a particular card, only one of the suits or only one of the numbers? What else could we bet on? Yes. Well, that would be like 100%. Okay, sure. Right. Anything else? Just say it. Sorry? Pick a face card. What's a face card? Jack through King. Those that have pictures, right? Three cards in each suit have pictures, right? Well, to pick a face, that's going to be 3 out of 52. That's worse than the 2. Oh no, sorry. Yeah, you're right. That would be 12. You're right. 12 out of 52. So that's 23%, 0.23. So that's about 23%, which is still worse than picking just hearts. Black and red, thank you. So pick red card, since we used the hearts before. So pick red and that is going to be 26 cards out of 52 cards, which is exactly 0.5, which is your probability of 50% to pick the red card. So now you have various probabilities, and as you can see, the top number is always the frequency of how many cards that you want you actually have, and then divided by all the cards in the deck, which are all possibilities. That includes the stuff that you don't want, right? But that's a game, you are picking, right? So the first one is there's only one there's only one 7 of hearts. It's red. So there's only one 7 of hearts, and that's why it's 1 over 52, and that's absolutely worst case scenario that we can, right? So if you are creating a game of chance, right, to involve the money or whatever, then this should be the highest payoff, because you win in 51 ways. If you are the one who owns the game, right, and someone else comes in and picks the card, you win 51 out of 52, and they win only 1 out of 52. So you win 98% of the time, right? Which means that if they win, the higher payout is okay. Hearts, that's a quarter of a deck, or 52 divided by quarter is divided by 4 is 13. So 13 cards are hearts. Each suit has 13 cards, and then you have a quarter as a probability, and you go down between the two suits. So you have hearts and diamonds. They are both red, and they have 26 red cards. So 26 out of 52 to come up with this. So you keep playing this game, and the only formula that you have is this one. You count the number of things that you have, and then probability is frequency divided by all possible outcomes. So all we need to write now are the properties of probability, and that's it. I hope you're not disappointed, but that's all. We can take a look at another example, but okay, so basic properties. Number 1, probability is always between 0 and 1. Because 1 is 100% and 0 is no chance. So those are actually our other two. So probability equal to 0 means event cannot occur. A good example is college administration making a rational decision. That's one of the good examples. Number 3, probability of 1 means the event must occur. That would be like college administration making a wrong decision. It's probability of 100. I'm serious. Yeah, right? Think. So now, everything in between can go either way. And we've seen it with cards, right? If you want a red card, if you want the heart, if you want, whatever you pick, there is always some kind of a probability, and these probabilities are always these decimal numbers here in this peanut. All right. So, and then we can also move the decimal, right, and make it into a percent. Just need to make sure that you see this decimal point here, because this is 7.7%. This is not 77%, right? 7.7% right there. Good. Is there anything else that we need? No, that's it. Bye.